talk about this page 2, which is what you need to be able to do. Okay, and that is to create segments that are a specified or fixed length. And so here's how to do that. Okay, we're going to start with a single point. And what we're going to do is we're going to translate this point. We're not going to deal a whole bunch with translations and transformations in this class, but we are going to, for this assignment, and any others where you're specifically asked to find given lengths. All right, so if you leave your the point that you just selected or created, leave it highlighted and go up to this transform dropdown and select translate. What translate does is it's going to create a new point that's a specific length away from the original at a specific angle from the original. So here we want a 3 centimeters, so we'll change the distance to 3 centimeters. And the fixed angle is based on an angle rotation. Angle rotations will begin at the far right. So the x-axis of a coordinate plane would be 0 degrees, and you'd rotate counterclockwise. So right now, the angle that this would translate is 90 degrees. So if you started at the positive x-coordinate on an x-axis or on a coordinate plane, and you rotated 90 degrees in counterclockwise, you get a point that's directly above. We don't want our new point to be directly above. And so what we wanted is we want it to be directly to the right. So go ahead and just change that fixed angle to 0 degrees. And that will put it, and you can see here it created it right there at directly to the right of this, and hit translate. And now you have that new point. If you select the original point as well and hit Control L, you've created a segment, and if you measured that, you would see that it's exactly the length of 3. And if we just repeat this with lengths of 5 and 9, so we have a point for 5 and a point for 9. And if I highlight my point, transform, select translate, change this to 5, leave our fixed angle at 0 degrees so it's directly to the right, select our original point, hit Control L to create your segment. This is going to be our 5 centimeter segment, and then do the same thing with our last point. Create a point and select it, transform, translate. We want this one to be 9 centimeters at 0 degree, translate. It creates that second point. When you connect it here using Control L, you now have your 9 centimeter side. So if I wanted to measure these to confirm that they're the right measurements, I can select them both at the same time, hit measure. The lengths will appear right below the previous one. So here's my sides of 3, 5, and 9. All right, now that's just setting it up. Okay, what you then want to do to create your triangle is you want to begin with the longest side. Okay, so I'm going to take the side that was 9 centimeters. And what you want to do is you want to create a segment off of each endpoint that's these given distances, 3 and 5. And the way that you're going to do that is you'll select the endpoint. You're also going to select one of the distances. By selecting the distance, you're going to tell tell SketchPad that you want to create a circle at this selected point with this selected radius. And that's under the construct command, circle by center and radius. So when you hit that, what that means is that any segment you draw from the point E to anywhere on this circle, these are all exactly 3 centimeters from E. And you're going to do the same thing from the other endpoint. If we select the other endpoint, we choose the other distance, 5 centimeters, and we're going to create a circle from this center with this radius by choosing construct, circle by center and radius. And once again, we have a length. This length is 5 centimeters. This length is 3 centimeters. And what do you notice here visually? Can you ever enclose a space with those? No, they're never going to intersect each other. And so this should have been something that you anticipated anyway, because based on the triangle inequality theorem, what do you know about the 2 smaller sides of a triangle? They have to be greater than the third side. Is 3 plus 5 greater than 9? No, so it should make sense that it's not going to intersect. What do you think is going to happen on this, the question number 5 here, with sides of 4, 4, and 8? Where will those points intersect? Here are the 2 smaller sides. Are they greater than the third side? No, in this case, they're exactly equal. So those two sides will meet right at the midpoint, right at the midpoint, or in this particular case, but right at the same point on that longest side. And so once again, they still won't enclose a space. So when you answer your question, you'll just say, no, it can't be done. The reason is the sum of the smaller sides is not greater than the longest side. Okay, I want to show you, I'm not going to do number 5 because it's very similar to what I just did, but number 6 I will show you. So let's talk about here creating a triangle with sides of 4, 4, and 5. Okay, so I have only 2 different lengths, and I've already created 5, so I can pull this one down because that's already a length of 5. And so I just need to create another point, and I'm going to translate that. So transform, translate. I want this one to be 4 centimeters, again, directly to the right, so 0-degree rotation. And then I highlight those two, hit Control L. That gives me my distance of 4. And I can confirm that with a measurement. All right, so the next part in this is you're going to kind of do the same exact thing. Start with your longest side, which is 5 centimeters. And you're going to create a circle from each endpoint that has the given distance. In this case, the distances will be 4. So if I highlight my endpoint and my distance of 4 centimeters, construct a circle. And I'm going to do the same thing from my other endpoint and my segment length of 4. I'm going to construct a circle by center and radius. And now notice there's 2 places that you can select for your triangle to create this segment or this triangle with sides of 4, 4, and 5. You can select the intersection above or the intersection below the original line. So I'm going to go ahead and just select the intersection above. Notice I'm highlighting all 3 of the endpoints of my triangle. I'm going to hit Control L and it'll create the triangle for me. I'm then going to just highlight my circles that I use to construct everything, and I'm going to hide those. So here is my triangle created with sides of 4, 4, and 5. If I measure these, it's going to confirm that. Okay, 4, 4, and 5. And so if I wanted then to find my vertex angle, so I can just highlight my sides, measure this angle right here, highlight my sides, and measure the other angle. As you would expect, those 2 angles are exactly the same, and these confirm the property that we talked about with isosceles triangles, which is if 2 sides are equal, what do you know about the angles opposite those sides in a triangle? They're also equal. Okay, so angles opposite equal sides are equal. We know that sides opposite equal angles also equal. And so that's the property that you would be seeing by taking those measurements. All right, let's take a look at the next page, which is the other one that has some questions on it. Okay, I'm going to show you 2 ways to complete this. The first way is a little bit more complicated, but it explains things and shows you the way that you would do it by hand as well. The second way is a little bit easier as far as what you actually physically manipulate, but it's based on an understanding of relationships. Okay, so let's talk about the first one. So if we try to follow these instructions and construct an angle that's congruent to angle E at point G, what we would do is go back to that one of the second construction that we did, which was duplicating an angle. And the way that you duplicate an angle is you construct an arc that passes through both sides of an angle. So anytime we construct an arc, we're just going to do a full circle. And so I'm going to change this back to a solid line. So here's our first arc. It intersects our angle here and here. I'll go ahead and label those points. So those are your 2 intersections. Okay, once we construct an arc that intersects our angle at 2 points, we're going to duplicate that arc onto the location where we are duplicating our angle. So we need to take this circle in green, and we need to draw a circle with the same radius from point G. And we're going to do that the same way that we did in the last slide. Select G, select the radius that we want to use for our circle, and then construct circle by center and radius. Okay, the second part of duplicating an angle is we're now going to measure the distance from these 2 arc side intersections. So I'm going to draw it in right here to show, but this is the length that we want to measure, and we're going to measure it with a circle. So if we place our compass tip or the center of the circle at one of these intersections and extend it to the other intersection, what we're going to do to duplicate this length here at this other, the duplicated points intersection, we simply do, again, what we did on these others. We're going to create a new circle whose center is this intersection and whose radius is this radius right here. So if we select the center point and this radius, the radius of the smaller circle, we can construct a circle by center and radius. And that intersection, if we connect it back to our original endpoint, is going to be an angle that's duplicating angle E. So the easiest thing to create this angle is I'm just going to go to my segment, my drawing tool, and I'm going to select ray. And if I start at point G and extend through this intersection, I now have an angle that if I measure this angle right here, it's going to be identical to the measure of our original angle E. If I measure that, you see that those are identical to each other. Okay, so once you duplicate your angle right here, you're then going to enclose the triangle by extending this ray. So if I go back to my ray tool and I extend from E to C, it shows me that my intersection, where the vertex of my triangle is going to be, is the intersection of those two extended rays. So here are my endpoints, or the vertices of my triangle. If I hit Control L, it creates the triangle. It turns those lines into reference lines. I can either hide them or leave them as dashed lines. Okay, I already know my angles are equal. And what would you expect to happen in a triangle to sides opposite equal angles? They should also be equal. So if I highlight my two sides, measure those, I get confirmed that those are equal in length as well. All right, now, I told you there was another way that you could approach this that's based on the understanding of the relationships that are being created here. Okay, and so if you need to construct an angle, so if you're thinking of this, construct an angle that's equal to this angle over here, what kind of a triangle, again, are you expecting to see? When you extend these through, these should be a isosceles triangle, right? So the other thing, or kind of the next thing to think about, is the one place where you know or the one way you know you can create an isosceles triangle is if you created a circle and then you drew in two radii, you know those radii will be equal. And then if you connected them, you'd form this isosceles triangle. You can always create an isosceles triangle inside of a circle. Okay, so using that concept, what we can do is we can think that EG would have to be a chord of this large circle. Okay, and so if we wanted to find where is the center of that chord going to be located, what construction method did we use to find the center of a circle? We took a chord and we did what with it? We found its midpoint, and we drew a perpendicular through that midpoint, right? And that perpendicular is going to pass through the center, and we just repeated that with another chord. Well, we can use that property to complete this construction. If you highlight your base, and you use Control M to find your midpoint, and then keep M highlighted and select that base again, you can construct a perpendicular through there. So here is our perpendicular bisector. And so all you'd have to do to create your figure is construct a ray from point E, just extend EC, and then just intersect or connect this intersection of the perpendicular bisector and that angle with point G. And then once again, when you highlight these 3 points and hit Control L, you've created your isosceles triangle. So that's the easier construction. It's just based on the properties, to be familiar with what properties make this true. And then if you measured the angles and measured the sides opposite those, you're going to find that property that we've already discussed, which is in a triangle, sides opposite equal angles are equal, and angles opposite equal sides are equal.